Here's my negative plates. Here's the anode plates before I roll them up into this configuration. And then encase them inside of the Scotch-Brite green scrubby material. On this anode, where I connect this wire, I'm using a 14 gauge. I strip it down and I run it through this hole and solder it up, and then I cut it off. On the two outer ones, I cut the connection off, and then the center one I leave as the actual wire connection, negative wire terminal. And I'm going to use these stainless steel cups I get for $2.50 each from Webstaurant. So these stainless steel cups, the 30 ounces, it's going to be part of the casing will be the cathode. So this wire just happens to solder to this material nicely, which I was surprised it does. So this wire will be soldered somewhere in here. And then there'll be another wire coming off of here I haven't attached yet. It'll be a stainless wire. So these batteries are really old. They're, I don't know, 7 years old. They're dying, and I need to replace every one of them. Look, I used up the stud so much that I had to switch over to that. They need to all be replaced. So that's I need to spend $1,000 or $2,000 on batteries. It's just one of those things you got to do now and then. But because of this, that's why I started this project. Although I wasn't really expecting to have much progress or much luck, I should say. I've tried this before, and it's a challenge. So I'm using this Scotch-Brite material and hot gluing it around the zinc anode assembly I come up with. This isn't one of the craziest projects. 12-volt battery. Some of these crazy projects I get into. Here's my battery box design. I got these little cups as a sleeve. See, I can't let these touch each other because the outside of the can is part of the positive anode, or no, cathode. So this keeps them from touching each other. I could have taped them all up, but this is much better. So I had a little bit of a problem for a while getting the voltage correct. I wasn't, my mixing process, I just changed it and I didn't realize it, and I had to go backtrack, and I figured out what I was doing wrong. So now I have to remix these four because I'm making a 12 volt here. Another late night. Look at this contraption. It's working out great, actually. Although I made this just a little tight. I've got to make these just a hair smaller next time. I'm retrieving the powder out of 4 carbon zinc batteries. That's the number I've come up with, 4 AA's. So that's how much manganese dioxide and whatever else they have mixed in that powder out of 4 AA carbon zinc batteries. So I made these pads just a little bit too big. They work, but I'm going to have to shrink them just a little so I can get it down further in the container. And for a bit there I thought I was having a problem using the stainless, but it wasn't the stainless, it was my mixture. I wasn't doing it consistently. I started doing it in a jar, and then I was leaving some of the powder. Well, you got to get it all in there. So I have 4 of them I have to redo. But anyways, this one's working great. Every one of them, as soon as I put the as soon as I put everything together, after I mix the powder, and then I get it all hooked up, it instantly goes to the voltage. So it's average, it's usually around 1.075, so 1.048. And then I crimp the stainless wire to the copper wire. Okay, here we go, guys. Here's my crazy design. It's working great. Here's the pad. Here's one cell, all filled up. 1.07, 1.08 volts. Holding strong. Okay, here's my first 6-volt battery. I gotta wire nut these together, and then I'm gonna run 2 wires out right underneath this handle here. Here's my 6-volt battery. Well, 5.77 volts. So each one's almost 1 volt right now. And normally top over 1 volt, so I think when it starts charging, maybe it'll be like 1.1 volt. Either way, it's close enough to 6 volts to work. 2 of them together and make my 12 volts. They were putting out about 11 volts, all 12 of them together. A couple of them I need to redo, but they were close enough. Most of them were fine. So I've got like 20 volts going in here now, charging them up. It's a little strong, but I got to connect it to the solar panel. Well, I've got LEDs going anyway. Wouldn't run the TV, doesn't have enough power. It's a start. Now I need to see if I can up the power on them. I'm going to try adding nickel cadmium to one and see what that does. Put out 17.8. It's dropping because I just disconnected it, but still strong. 17 volts, 17.8 volts. Now I'm going to see if it'll run this fan, which I don't know why it wouldn't, but you just never know. So will it run or not? It's not super powerful. But it's running. I charge them up with this 120 volt, 120 watt solar panel. Later on they'll start bubbling as the hydrogen builds up inside of them. They bubble after a while. So they're working great. They're just not super, they just don't have a lot of amperage. Now I've tried to get the amperage up, but so far I haven't had much luck. I haven't put a lot of time into this yet, so it's back and forth on different projects.